Hi, my name is Moina. Uh, Today's topic is to understand the flow of neural networks using keras. Before starting the topic, I like to discuss the basic difference between keras and TensorFlow versus TensorFlow. The first difference is level of abstraction. Keras is basically built on TensorFlow as it is a high level API and TensorFlow is a low level API. Because of the low level API, TensorFlow is more flexible than Keras. But in deployment point of view, Keras is more deployment friendly and easy to use. You you don't need to understand the whole things of neural networks or nitty gritty details of neural network to understand the Keras. So I move to the neural network component. In neural network component, we have layers, we have models, we have optimizer, loss function, and metrics. Basically, in Keras. Its layer is a building block of neural networks. Our model is a stack of neural networks, basically the collection of all layers. Optimizer and loss functioner work together. Using optimizer, our main intention to reduce the loss function and stabilize the model. And the matrix is a performance evaluation method. Using matrix, you can evaluate the performance of your machine learning method or machine learning models or neural networks during training and testing phase. In keras, first you need to define the input layers. Then define the layers of the model connecting to the input layers, means the hidden layers. Then you define the output layers. Then you compile the model and train the model, feed the model, and later on using the metrics you can find out the performance of your model. So and one more thing to note that data pre-processing is not as much required in neural networks because we are using activation function. Because as we are using activation function, we already scaled it. We already scaled our input, so we do not require the data pre-processing in neural network. So we need to define the input layer. We need to define the hidden layer. There is various kind of hidden layers. Fully connected layers in image processing, convolutional layers, pooling layers, working with convolutional layers, spatial dimension. In NLP, you are using recurrent layers. Not only NLP, also in time series, also you are using recurrent layers it's because it deal with sequential data. To prevent the overfitting, we are using dropout layers and batch normalization layer. In here, we are discussing the fully connected layer. The fully connected layer is known as dense layer. It's the most basic type of hidden layers, and it will use many of many of use cases like image classification to language modeling. We are using gradient descent with the loss function. Gradient descent as a optimizer to stabilize or to stabilize or and to minimize the loss function of the neural network. And the main thing is that okay, it is connected with every neuron of the previous layer. It is fully connected. It's connected. Every neuron is connected with every neuron. In here, we are using the example of a regression example. How do we do? We import the numpy, then we import the keras from TensorFlow. We generate some data for regression purpose. Random data having 5 features means 5 columns and 100 rows means 100 data point, and random output data 1 column and 100 data point. How do you define the model architect? First, we need to keras.sequential, this object of keras. Inside the sequential object, you need to define the keras.layer.dense. Inside this function, you need to specify the number of neuron you want to use in input layer. In here is 10. Then you need to define the shape. In shape means 5. 5 means 5 features. So just can imagine that we have a table of 5 features, and how do you feed it to the neural network? Uh, we just transform it, and the 5 features is becoming the 5 rows, and then row wise it will insert into neural network. So you can see here it is 5 and also it is 5, but in here it is null. The activation function is relu. We will discuss in separate video what is the activation functions, and then we need to uh, add some hidden layers of dense 3 hidden, and we need to one more hidden layer we need to add, and then is output layer. Then we need to compile the model using MAC loss and optimizer Adam. So we have already discussed optimizer and the loss are working together. The main focus of optimizer is to reduce the loss function to stabilize the model. Then train the model. How to train the model? Model.fit x y epoch is 1000 for the computational flexibility. I make it 100, and verbose. Epoch is a single An epoch is a single iteration over the entire input data, and verbose is the way of displaying the output. We can control we can control how much output is to display, as well as we can control the iteration over the neural network using epoch and verbose. So in the evaluation part is MSc dot evaluate xy verbose 2 and print mean square error. If we can run it, we can find out this the training for every epoch. Like if you can uh, start from 1000, I make it 100, but first I run it on 1000. So just run it. Yes, we can see first epoch 1 of 1000, epoch 2 of 1000. When the entire data move one iteration, it have a loss of 0.3312. And then you can see, you can observe while the epoch is increasing and the loss is decreasing, and after some time it is stabilized. You can see it is stabilized like 636, 635, 634. It will not change after 4 epoch. It will not change. The last epoch it's also not change. So can understand like this. K 23rd epoch, just a minute. Yes, uh, like uh, like 85 epochs means 85 times, 85 iterations. It will the model will stabilize. After 85 of iteration, the model will stabilize, and then we can understand that loss, the decrease in loss is very less. Then we can understand the model is stabilized like this because 62.9, 62.8, and we have a mean squared error. And how do you test the data? We make a random data for testing purpose. So you need to evaluate it also in test data and test result. The test data we have here, we have here, and the test result we have here. We need to evaluate it on it is we have evaluated it's on training phase, and now we are evaluated it on testing phase. So if you evaluate it, let's see, you can see the loss is 0.69, and in training phase the loss is 0.68. So the model is good. It's a toy model. The model is good. Sorry, it's a simple mistake. The mean square error is 0.628, and after testing it we have 0.053. So the difference between two is not very much. So you can say the model is is good enough to predict the data. In the type 2, we can, it is type 1. We are using it type 2. Type 2 is very easy and understanding point of view. In type 2, we import the input and dense. We import the model from keras.model and put and dense from keras.layer, and then we make a data for 100 data point and 5 features, and 100 data point and 1 features in training purpose. Why? For evaluation we need to specify more data. We need to make some more random data for it is evaluation. It is for training purpose, it is for evaluation. So how can we make the model? First we need to specify the input layer. It's very easy. You just share input dot zip 5. Why 5? Because the feature is 5. And then we need to specify the hidden layer. The first hidden layer, 50 neuron activation is ReLU and the input layer. So you can imagine that the first input layer, the the result of first input layer feed into the hidden layer, and the result of first hidden layer feed into the second hidden layer, and then the output layer. It is dense one, activation is sigmoid and hidden layer. Then we can compile the model, make the model, input as input layer, output as output layer, make the model, we made the model, and then we compile the model using optimizer Adam, loss binary, and matrix accuracy. It is training phase. How do you train the model? Model.fit, extend train, epoch, I take it on 10 for computational easiness. We take batch size 32 and validation data X val, Y val to evaluate the model in training phase. If we run this thing, I can say the same thing. It will stabilize. You can say that I make one just in epoch. Make it 100. Adding epochs, you can fine tune is also a way to fine tune your model to increasing the epochs. So you can say that 69 to 68, 68 to 687, then 686, then 685, then 684, then 683, 681, then 67, 678, 681, then also 67. So you can understand after some epoch, after 39 epoch, the model is stabilized basically. And how do you test? For testing purpose, just run the code. We also make a random test data and make a y data. We need to evaluate it in testing phase. In here, it says that the make all arrays contain the same number of samples. So in here we make a mistakes. Okay, we do not enter the 0. The test data is 100. Need to be 100 to uh, cancel this error. So now we can have the 0.7 the accuracy, and the we can say here also is 0.7 loss. So we can say okay, the model is stable. So that's all. Thank you.